All right, second part. You guys have probably taken off with that other previous section there, I'm sure. There's a lot to take in. But where we left off was with determinants, and I didn't quite get to finishing number 5 before that video cut out. But the way it works is you take those middle values, and those become the coefficients of 3 determinants that because this is an odd square, that's a 3 by 3 square as opposed to a 2 by 2 square. One of the things is we have minus plus between each of these 3 determinants. So what we have is that blue -1 times the first determinant, red -1 times the second determinant, and green 1 times the last. And we're going to go minus plus minus, as you always start with a minus with an odd matrix there. The 4 and the 5 are the values that are not in that middle row, and they're not in the blue column there with that blue -1. The 3 and the 5 are the values that are not in the middle row, and they're not in the middle column where that red -1 is, and green correspondingly. The determinant is the difference of those cross products. So you have from the top left, each one, so like for that first blue matrix, the 4 times the -3 produces the -12. The 5 times 2 is the 10. So what you have there is the difference of the cross products starting in the upper left-hand corner is how you get the determinant of each of those those are little mini determinants from the larger 3 by 3 matrix we started with. In the end, -19, that's your determinant of that 3 by 3 matrix. Again, it's for use in other calculations is all it is. We can tell in number 6 the inverse of a matrix exists if the determinant is not 0. So an inverse matrix is a matrix that undoes another matrix. It's a means of getting the unit matrix in a product. So if you multiply the inverse times the original matrix, you get the identity matrix. And I think I said the wrong thing, but you get the identity matrix, which we'll talk about a little later. But I can do the determinant of A. Those cross products, as I mentioned, the difference of them, I get 10. Great. That means A6 has an inverse. And you go to number 7. And I think I wrote, this is some notation things you want to know. An inverse of a function is a to the -1. So we're going to go ahead and do the inverse of number 6 because it does exist. And the way you get the inverse is you take 1 over the determinant of a, which we have 10, multiply it through an adjustment on matrix A we have in number 6. So watch this carefully. It's not going to be 1 over determinant A times the matrix. It's going to be a little augmentation to that. What we're going to do is swap the upper left and lower right pieces, and then we're going to negate the lower left and upper right. I've got it notated there. So swap the upper left and lower right, negate the other two, and it looks like this. So we would do 1 over the determinant times those values that I just adjusted, and there it is. You multiply through that 1/10, and you get your inverse matrix. So here we are. Multiply that through. Voila, that's your inverse matrix. The last parts of this, just a quick review. Substitution for 9 and 10. Isolate one variable, substitute in the other equation, solve for like x or y, and then put it back to solve for the other missing variable. You're good with substitution. We've done it with parametrics recently. Elimination, you want to multiply through by a value. The goal is to eliminate one variable. If you eliminate more than one, you might have trouble. Like in this one, we end up eliminating both. And we get 0 as -18, which doesn't make sense, so there's no solution. These are actually parallel lines. That's just to get you kick-started. The rest is open a book, talk to a friend, work on your pre-quiz part 2, and I'll see you guys tomorrow.